All right. So permutation. Let's look at what is permutation. Okay, the arrangement of objects taking into account the different orders of arrangement is called permutation. So the arrangement of objects taking into account the order is called permutation. All right. All right. So in a shorter definition, the arrangement of objects where the order matters is called permutation. All right. So let's look at an example. Let's look at the arrangement of letters A, B, and C. All right. So these are like 1, 2, 3, 4, 5, 6 different arrangements. All right. Different arrangements of the letters A, B, C together. All right. So what do we mean by order matters? When we say order matters in permutation, that is the arrangement ABC and CBA are two different arrangements. All right, so we say order matters. See, the order of the letters A before B before C is different from C before B before A. Otherwise, okay, so these are two different arrangements. So that is permutation for you. So these are the 6 different ways the letters of the word, the letters A, B, C can be arranged or permutated. All right, so these are the permutations of the 3 letters A, B, C. See, the order matters. A, B. All right, so the number of ways 3 letters or 3 items can be arranged, okay, where the order matters is called a permutation and is given by n factorial, okay, where n stands for the number of items. So if it's 3 letters or 3 items, it can be arranged 3 factorial. That's 3 times 2 times 1, okay, and that's 6, okay. If it's 4 items, all right, it will become 4 factorial ways. So that's 4 times 3 times 2 times 1, and that's going to give us 24 arrangements or 24 ways. So that's what I mean by this. So this 4 factorial, 3 factorial, and all right. So arranging the 3 letters A, B, C, you see that there are 6 different ways these letters can be arranged. So there are 3 letters. So there's a way you can go about it. So let's explain. So let's look at this. In general, the number of different arrangements of n different objects is equal to the product n times n minus 1 times n minus 2 down to 1. So this product can be written as n factorial. This exclamation mark is called factorial. So basically applying it to A, B, C, there are 3 letters in A, B, C, right? So 3 letters A, B, C, okay. The number of ways these 3 letters can be arranged is 3 factorial. So that's 3 times 2 times 1, and that's 6. All right, so you can practice it for yourself. The number of ways, number of arrangements of 4 items. Assuming those items are A, B, C, D, you can see it's going to be 4 factorial. That's 4 times 3 times 2 times 1. That's 24. You can see if this was A, B, C, D, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 24 ways that the letters A, B, C, D can be arranged where order matters, okay. So CDBA is not taken as something as DCBA. The order of the letters matters. So 24 ways, okay. As yes, that's 4 factorial. All right, so what I just said so far is that the arrangement of objects taking into account their different orders is called permutation. And then we said the number of different arrangements of n different objects is equal to n factorial. This symbol, this exclamation mark symbol, is a symbol for factorial in this mathematics. All right, so let's look at a typical example. Let's say we have this question. It says, find the number of permutation of the letters of the word Kano. Now, basically, there are 4 letters, and they are all different. So 4 letters, basically 4 factorial. And that's 4 times 3 times 2 times 1. So there are 24 ways, different ways these letters. All right. How about the permutation of n objects? Taking r at a time is denoted as n permutation r. Well, what do we mean? Let's look at an example to explain. Let's look at this example. It says, find the number of ways the first, second, and third positions can be taken by 10 candidates in a scholastic aptitude test, assuming there must be no tie. Find the number of ways the first, second, and third positions can be taken by 10 candidates. Alright, so this is basically 10, taking 3 out of 10. Alright. Okay, so now let's look at the number of ways of permuting n objects, taking n at a time, where there are n1 objects alike, n2 objects alike, so on and so forth, is given by this formula. So basically, just find the factorial of the total number of items all over the factorial of the number of those items which are alike. All right. So we're going to look at a typical JAMB question to explain this particular what we call conditional permutation. So this is the formula. N stands for the total number of items, and then these are the number of alike. Alright, so the permutation of n objects taking r at a time is denoted n permutation r. And this is symbol, and this is the formula. So we say n factorial all over n minus r factorial. Okay, so in other words, say to find the permutation of a partial set, find the permutation of the full set, then divide by the permutation of the items left behind. So it's a different way of saying the same thing. So let's go back to the example we talked about. So the example is here. We're saying that taking 3, number of ways 3 can be taken out of 10. So it's just like that. And then apply the formula. Alright, so let's look at this typical JAMB question from JAMB of 2019. It says, in how many ways can the word mathematician be arranged? In how many ways can the word mathematician be arranged? So mathematician has 13 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it has alike objects. How many objects are alike or indistinguishable? It has 2 M's, 3 A's, it has 2 T's, and 2 I's. So, alright, so we have mathematician, we said has 13 letters. You can count it, there are 13 letters. So number of items is 13. Now the alike objects are 2 M's. There are 2 M's there. They are indistinguishable objects. That means we cannot tell the difference. 3 A's. We have 3 A's. We have 2 T's and 2 I's. So arranging them by formula is like this: n factorial is the total number. Then each of the, so we have 2 M's, 3 A's, 2 T's, and 2 I's. So apply your calculator to this. 13 factorial divided by that. Calculator will give you this number as your answer. So that's just the way to solve that. Alright, so let's also talk about what we call combination, because the topic is permutation and combination. Let's talk about combination. Arrangement of objects in which order is not taken into account is called a combination or a selection. So a combination is basically a special type of permutation in which the order is not taken into account. Alright, so it's let's look at how it looks like. Okay, so we say now the number of ways R objects can be selected from N objects without much regard being paid to the order of arrangement is denoted N choose R. Alright, so for permutation, if we are particular about the order in which 2 books, let's consider the selection of 2 books from 3 books labeled A, B, and C. Alright, we want to pick out 2 letters out of 3 letters. So the different ways that these 2 letters can be arranged, alright, out of the 3 letters are this way: A, B, B, C, A, C, B, A, C, B, and C, A. Now observe that A, B, and B, A are 2 different arrangements. So that's how permutation is. But for combination, A, B, and B, A are taken as one. B, C, and C, B are taken as one. A, C, and C are taken as the same. Alright, so to summarize, the symbol for combination is N choose R. That's N choose R will be the permutation of that all over R factorial. Okay, so simplify, if spread that out, this is N factorial. N permutation R is simply N factorial all over N minus R factorial. Then since we are dividing by R factorial, is R factorial again. So in English terms, we're saying to find the combination of a partial set, find the permutations of the full set. Divide by the permutation of the items left behind, and also divide by the permutation of the selected items. So this is what it looks like, combination. Alright, so let's look at this JAMB question from JAMB of 2018. It says, out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? Alright, so this is a question of, just like I said, if we have an operation that, in which one operation can be performed in P ways and another operation can be performed in Q ways, the number of ways of performing the 2 operations, one after the other, is P times Q ways. Okay, so let's look at this. So let P be the number of ways of forming 3 consonants. Alright, sorry, number of words of 3 consonants, and let Q be the number of words of 2 vowels. So also look at this point before we start our examples on combination. It said if an operation can be performed in P ways, whether it's an operation of permutation or combination, if that operation can be performed in P ways and another operation can be performed in Q ways, then the number of ways of performing the 2 operations one after the other is P times Q ways. Alright, so we're going to apply this rule to some questions. Now, before we start, I want to take note that when you see the word selected or chosen or formed in a question, it refers to combination. But when you hear the word arranged, it's connected with permutation. Take note of that, please. Alright, so P is basically 7 choose R. That's this is a symbol for combination. So let P, so then P will be 7 choose R, 7 choose 3, and Q, the number of words will be 4 choose 2. Okay, because we're talking 2 vowels out of a total of 4 vowels, 3 consonants out of a total of 7 consonants. So apply your formula for combination. 7. So this is formula for combination. For 4 choose 2 simplifies to this 6. 7 choose 3 simplifies to this. So the total number of words that can be formed is 210 words. Alright, so that's just how it goes. 3 out of 7, 2 out of 4. Alright. Alright, so let's look at this JAM 2019 question. It says, in a committee of 5, which must be selected from 4 males and 3 females, in how many ways can the members be chosen if it were to include 2 females? Alright, so we have a committee of 5. Alright, maybe there's a committee for planning something or organizing a party or something, and it must include 2 females. So let P be the number of ways of selecting the 2 females, and let Q be the number of ways of selecting the males. Now that if we have selected 2 females out of a total of 5, then that means to make up a committee of 5, that means we are left with 5 minus 2, 3 males. We can only select 3 males. So because of that. Alright, so it's a committee of 5. It's a committee of 5. And we are given the condition that it must include 2 females. So basically, the number of ways of selecting the 2 females will be 3C2. That basically we're going to select 2 females out of a total of 3 females, because we have a total of 3 females. So if you're selecting 2 out of 3, that's written as 3 choose 2. This for combination. We say 3 choose 2. Okay, and then that means we can only select 3 males, because the committee can only contain 5. So we take out 4 choose 3 for the males, because we have 4 males and we can only select alright, so we are choosing 2 females out of the total of 3, and we can only choose 3 males out of a total of 4 males, because we have a committee of 5. So 2 plus 3 make up your committee of 5. Alright, it must be 2 females, because that's the condition. So the members we're choosing for to include 2 females. So apply your rule for combination. Is 3 factorial over 3 minus 2 factorial 2 factorial times 4 factorial over 4 minus 3 factorial 3 factorial. So 4 choose 3 is simplified as this. 3 choose 2 is simplified as this. So break it down and you apply your calculator. Use your calculator. You get the answer is 12 ways. So that's how we'll solve this combination question.